Good evening, everybody. My name is Jackson Fulton. I am a student at IUP. I wanted to walk through my Intro to Database Management Systems class and tell you some things I learned through the first 4 modules or chapters, if you will. What I've done is I've taken 2 points from each module, and I wanted to just walk you through them and tell you what I learned. All right, let's begin. The first thing I really wanted to touch upon was the database management systems, the DBMS. A database management system, or DBMS, I'm going to use DBMS, is the software that allows users to interact with data stored in a database. For this module, when I heard the word database, I thought of it as just stored information. But now I can understand that without a DBMS, the data would be disorganized and difficult to manage. The DBMS controls how data is stored, retrieved, and secured, making it essential for businesses and organizations that rely on accurate information. And let me get my little trusty pointer. And I put some bullet points here. I said it acts as an interface between users and stored data, organizes and manages data efficiently, controls access and security, and allows data retrieval, updates, and management. Without a database management systems, users couldn't easily search up data for whatever they need. Data wouldn't be organized efficiently, and security would be difficult to maintain. Second thing I wanted to touch upon is the advantages of having a properly designed relational database. We're going over relational databases out of all the types of them, and I figured this was important topic. So this module showed me how important proper database design really is. When a relational database is designed correctly, it reduces duplicate data, improves consistency, and enforces integrity rules. That means the information businesses rely on is more accurate and reliable. I learned that design decisions, made early can have long-term impact on performance and decision-making quality. So here's some of the bullet points. Basically everything I just said: minimizes data redundancy, improves data consistency, enforces referential integrity, increases security, improves decision making. Without a properly designed relational database, poor design causes incomplete or inaccurate reports. Good design improves business development. I just can't see with my face in the way. And reducing redundancy prevents errors. So on to Module 2. Module 2 was the relational module, and first thing I wanted to talk about was how tables connect in a relational database. In this module 2, I learned how relational database connect tables through primary and foreign keys. A primary key uniquely identifies each record, while a foreign key links related tables together. Understanding this helps see how databases prevent duplication and maintain structure. These relationships make large systems organized and efficient instead of chaotic. So, primary key, just talked about that, uniquely identifies each record. Foreign key connects related tables. One-to-many relationship structure data logically and prevents duplication and inconsistent data. The second thing I learned was retrieving data with queries. This module also introduced queries and queries by example. A QBE. A query allows us to ask structured questions to retrieve specific data. I learned how criteria along with and/or conditions can significantly change results. This made me realize how powerful logistic thinking is when working with data, especially when dealing with large data sets. Here's some little breakdowns of QBE. QBE provides a visual way to build queries, helps build criteria, filter records, and requires all conditions to be true whenever using an AND statement, and OR only requires one of the conditions to be true. On to Module 3. The relational module, specifically dealing with SQL. So I want to talk about the foundation of SQL queries. Learning the select from where structure helped me understand how SQL works logically. Select tells the database what to display. As you can see here, from identifies where the database comes from, identifies source tables, and where filters the results, filters the records. This structure gave me more control compared to visual tools, and it showed how database process instructions step by step. The second part of Module 3 that I wanted to talk about was how to modify data with SQL. We talked about updating data, inserting, and deleting, and what they do exactly. And this side focuses on how SQL can modify data using the update, insert, and delete method. I learned that SQL is not just for retrieving information, but it can also directly change stored data. That also means mistakes can have serious consequences, though, and this taught me the importance of testing queries carefully before making permanent changes. Deleting, and what they specifically do is update modifies existing records, insert adds new records, and delete permanently removes those records. And changes affect the actual stored data as well. And on to Module 4, I wanted to talk about the understanding of the database views. And when I learned about views, which are logical representations of data rather than copies, views allow us as users to see specific fields without changing the underlying structure. I found it interesting that views can improve organization and even provide a layer of security by limiting what users can access. And views provide a logistical representation of data, not just a copy. They display selected fields and records, they always show current data, and they help organize information and provide limited security by restricting access, which is what I mentioned already. And lastly, for the last part of Module 4, I wanted to talk about maintaining data accuracy and what that exactly means. So, integrity rules ensure that databases remain accurate and reliable. Entity integrity ensures primary keys are unique and not null, while referential integrity ensures relationships between tables remain valid. This module reinforces that databases are not just about storing data, but about maintaining trustworthy and secure information. Integrity rules ensure reliable database structure. Entity integrity, primary keys must be unique and not null. Referential integrity, foreign keys must match existing primary keys, and this helps prevent orphan records and ensures accurate and trustworthy data. Thank you for watching, and goodbye.